A relation is a collection of ordered pairs, x and y, that represent some sort of relationship between two sets of real numbers. X represents the input of the relation, which is called the independent variable. And Y represents the output, which is called the dependent variable. The set containing all X values is called the domain. Have you heard that before? And all the Y values is called the codomain. Now, a function is a special type of relation. Each value in the domain, each X, is uniquely related to a value in the codomain, a Y value. In other words, there is one and only one Y for each X. It's a little bit of notation. If F is the name of the function and you have a domain of A and a codomain of B, you say F maps A to B. And then if you want to talk about the relation between X and Y, you say Y is F of X. That doesn't mean F times X, it means of. The range of a function is a subset of the codomain, and the range includes all the values that are actually produced by the function. So the domain is the set of all input values, and the range is the set of all output values. Okay, in this example, we have set A, 7, 0, and 8, set B, 1, 2, -4, and then the arrows represent the relation which we'll call F. Domain is the set of input values, which is 7, 0, and 8. The codomain is the set of set B, which is 1, 2, and -4. But the range includes just the numbers in set B that get used, which is 2 and -4. Do you know what f of 0 is? Yeah, f of 0 is 2. What about f of 2? Okay, what would it mean for f of 2 to equal 0? We would have to have a 2 that maps to a 0. So f of 2 we say is undefined. There's no definition for what to do with a number 2 with this function. It's not in the domain. It's not in the domain, and your calculator, if you were doing something that could be calculated, would say domain error because you're trying to do something that's not in the domain. What about f of 7? And what about f of 8? Okay. Can you explain why the second one is not a function? Because 9 is mapped to two different output values. Okay, if you're still listening to this right now, I want you to post a screenshot of your weather app on Google Classroom in the comment section of this assignment. Okay, so you can have a function that has different types of relationships. This first one is called a one-to-one function because every x value has its own separate y value. There's no repeated y values. Each y value is only mapped from one x in the domain. The second one is called many-to-one because you have a y value that has multiple x's that are mapped to it. So multiple x values, many x's to one y. Some examples of this that we've seen so far is like a parabola is many to one because you can have one y value with two different x values. Like if x is 2, 2 squared is 4. If x is -2, -2 squared is also 4. So like 2 would map to 4 and -2 would also map to 4 in a quadratic function. In a linear function, there's not going to be any repeated y values. You can do what's called the horizontal line test to determine if a function is one-to-one or many-to-one. To evaluate a function means to determine the value of f of a, which is the output for a given value of a, or the input. So a function takes an input, does something to it, and produces an output out of it. So it takes an x, puts it through some kind of machine, and then the result is y, or f of x. And if the number that we're plugging in is not in the domain, then we say f of a is undefined. Okay, so what's the domain for number 1? So the domain is all of the x values, all of the input values, and then what's the range? The range is all of the y values, all the f of x values. What is the relation type? So this is one-to-one because there's no repeated y values. All of them are different. So 1x to 1y. What is f of 2? 5. Yep. 2 maps to 5. What about f of -2 plus f of 2? That's 8. Okay, what do you think 2f of -3 means? F of -3 is 4 times 2, which is 8, and then minus f of 0 is 1, so 5 times 1 is 5. So this whole thing is 3. Okay, what do you think this means? This is called composition of functions. You have an inside layer. So what is f of 1? It's -1. So we're going to replace f of 1 with -1. And then we're asked, what is f of -1? 0. Final answer. And the way you read that is f of 1. So you start on the inside and work your way out. So the next one would say f of -2. So we're going to say, what is f of -2? That's 3. And then we need, what is f of 3? That's 2. And then what is f of 2? That's 5. If you're still listening at this point, I want you to go back to the same Google Classroom comment section and comment your favorite color and fruit together. Color and fruit, like purple strawberry. Domain. So another way I like to think about domain and range, since domain is the set of all x values and x goes left to right, I want to picture like if you're a car traveling along in the x direction from the left to the right, are there any places that you would not encounter the graph? So like this case, it keeps going this direction and this direction. But do you see how it's getting wider? It's going to keep getting wider. So it's going to keep going forever to the right. So yeah, we would say from -infinity to +infinity, or you can say all real numbers. Now for the range, we're looking at the y values. So what I like to do is if I start at the bottom and work my way up, is there ever a section that I would not have graph from the bottom up? So from negative infinity all the way up to 2.5, there's nothing there. So the range starts at 2.5 and then it continues on to infinity. And we're going to put a square bracket around the 2.5 saying that it includes that number. Now we're estimating because we can't tell exactly, but we're saying that it includes 2.5 and every number above it. The relation type is many to one. You can see that with a horizontal line test. A horizontal line hits in two places, which means there's one y value that has two different x values associated with it. All right, what is g of 3? Is 5. G of 1.5 is 3, and g of 7. We don't know, but we know that it exists, or we're pretty sure that it exists. Now, in a lot of cases, you would be given an equation, and you could plug in 7 for the x value of the equation, and then you could calculate g of 7. But from the graph, we can't tell. All right, what about number 3? What's the domain? So we have a vertical asymptote at -1. I should have had that already drawn there, but that means that the function never crosses that line. It also means it never touches at -1. So if we're looking from left to right to state the domain's going to start at -1 and go to infinity. The range, all real numbers, or from negative infinity to positive infinity, because it goes forever down. And then this is increasing up forever as well. So it goes forever up. Okay, what relation type is it? 1, 2, 1. Any horizontal line I draw would only ever hit in one place. Okay, what is h of 4? Yeah, we'll say 0.25. And then what about h of 0? And then what about h of -2? It's undefined because -2 is not part of the domain. There's nothing here. What's the domain? -6 to 4 is part of the domain. It does not include the number -6, but every number up to it. And it does not include 4. So I'm going to use parentheses instead of the square brackets. But it also includes everything after 4 and everything before -6. So we would write the domain like that, from negative infinity to -6, then from -6 to 4, and then from 4 to infinity. So it really just does not include the number -6 and +4. So there's another way you can write that when you're not including a specific group of numbers. What about the range? Yeah, it's all real numbers because it goes from low to high. And even though there's a break right here, it's still covered in the middle there. Relation type is many to one because you can get multiple x values for just one y value. Okay, what is j of 3? That's about right there. What about j of 4? It never touches at 4. That's a vertical asymptote, so it's undefined. If you had an equation for this graph and you were to type 4 into the calculator or plug 4 in, your calculator would say domain error because 4 is not in the domain. What about j of 2? -0.5 right there. Perfect. Have a great day, everyone.